Welcome everyone to our third session. Super excited about this session. First one, we talked about scrolls. We dove in there a little bit. Bob, it was pretty good. We got into semis on the second session, and now we're going to talk about failures because this is one of the most important things you really want to understand. When a compressor has issues, when a compressor has failures, what do you do? What do you look for? What do you have to investigate to really find that root cause of the issue? And that's the big thing. It doesn't matter if it's a residential, commercial, industrial compressor. You need to find a root cause. Bob, how you doing, brother?
Good, pal. Very good. That's just to tag onto that, that planned maintenance that we all do and keeping good records are really important. You need to trend your data, amp draw, oil pressures, just to tag in a little bit to what you said there. There's really so much you can do ahead of time to minimize your chance of failure.
Yeah, and that's the big thing. It's like you need to log this stuff. You got to have a journal. You got to have a book. Those technicians that do, they're growing. I'm telling you, I know. I've done it and I've seen it. And you'll understand that site, that compressor, a lot more when you have that information because you can go back to it. Oh, here, this is what the resistance was, and if the resistance starts to change over time, then you start to see a trend happening. And they do this in industrial all the time on big compressors in industrial applications, big motors. They will use a megameter and they will check it each year and they'll log it to see how the windings of that motor is doing. So it's very important to do that. So Bob, good on you.
Yeah, in the teardown labs, they use a high pot, which is very similar also. And the mega ohm meter is there for trending purposes. Take advantage of that for certain, especially when you're dealing with the larger machines. It's automatic with the big boys like it's centrifugals and screws and those things. But you're dealing with these supermarket applications with semi-hermetics or scrolls. God, get all the information you can for sure.
Yeah. And you're not going to do it on every application. You're not going to, but there are times where you're going to want to bring those out and talk about it. So let's just get right into it. Let's talk about some compressor issues, compressor failures, things to look for, Bob. There's 5 or 6 different major compressor issues. And do you want to lay out a few of them for the crew?
Well, I think, first thing is make sure we can kind of get a grasp and as we move through these to understand the differences between mechanical failures or the events leading up to a mechanical failure and true electrical failures.
Yeah.
Because a lot of times a mechanical failure can lead to that electrical failure, especially like in an overheat situation and some of those things. And our first impulse is when we own that or mag that thing out or own it, and those windings are open and they're all burnt. And, we want to say it's electrical, but we have to learn to be very careful of that. And the advantage of having a serviceable compressor sure helps us with that. We don't always, we can't dive into that scroll or those other welded compressors or hermetically sealed compressors, if you want to use that term. But, the advantage of the semi-hermetic compressor, especially in our world, the supermarket and commercial refrigeration applications, whoever makes them, there's an advantage to that. And when something isn't right, you want to condemn it, get into that thing for sure.
Yeah.
Just kind of tagging, I think I'm going to jump slightly, just trying to set that up a little bit. But, learning the difference between that mechanical and electrical is really important. And there will be true electrical failures. No question about that. UL sets some pretty tight requirements for the testing and overload protection. And, there's a lot of stuff goes into all that. These motor guys and, all the components for the safeties and protectors, they're really doing their work ahead of time. But a true electrical failure is definitely much less. And I'll never forget my first cost trip, 1987, Glenn Hannigan and a few of those guys. And he liked to twist a cigar when he was talking. He didn't smoke it, but he would twist it. And he was talking about the 80% mechanical and 20% electrical. And I probably had 10 years into the trade. And I said, well, I guess I kind of raised my hand and sitting in the front row and said, I guess you haven't owned out a lot of compressors in the field as a factory guy. And of course, I ended up being the factory guy, but he looked at me, and just that cigar and he said, just hang on here a day or so. We'll have you straightened out, young man. And I'll never forget that, and that stuck with me, it really did. And then after completing that 3 days class, you really got to tie that together. I think we always classified when we were doing those classes and being a technical trainer around the country in North America, we always stressed overheat being
Yeah.
the most likely of the failures because
Yeah.
there's so many system issues that could lead up to that. Identifying those system issues and doing that planned maintenance, like we talked about, not only just on the compressor with trending data, but keeping them condenser coils clean and not overcharging and just, I mean, we could kind of go on. I don't know if you've got anything you want to show or add to that, but overheat is definitely a big problem, probably the number one cause. And I don't remember the exact percentages of each one. I know overheat was the number one and loss of oil was the least,
Yeah.
from what I remembered, but from our days of being on the road and doing them things. But the overheat is just it causes the damage, and it's usually kind of a slow death. It's not generally that right away death like we might get with a flood start. Flood start, they're pretty durable machines, but eventually something's going to not want to work or not turn
Yeah.
or compress that liquid. But so that's more of a quicker death. But overheat's usually a longer term issue that can be prevented.
Yeah. And I've seen compressor manufacturers over the last 10 years add so many new components to really help prevent that. And there's a lot of stuff inside the compressors to help reduce the failures. So Copeland put out tons and tons of core sense, for an example, which have overheat protection and
Yes.
discharge line temperature protections that you can add onto the system. Bits are with their IQ modules, and it goes on all these different manufacturers offering protection. And a lot of times it's optional. So you need to think about your customer. So in a residential application, are you going to buy a 30, 40, $50 piece of hardware to add to protect the system? Maybe, maybe not. But for a larger commercial application, for sure, HVAC or refrigeration, you're talking $1,000, $2,000, $3,000 compressor. A $50 component is really cheap insurance to protect your customer's equipment. And it's a good place to figure out if that was the fault, because you can buy DLTs that are manual reset. So if it goes off, your system's out, then you come back and you know that it went off on that while you weren't there. If you don't have like any monitoring system like a PLC, building automation, or a controller that's monitoring that temperature. So really important. There are options out there to protect from overheat. But yeah, I think overheat is probably one of the biggest ones through all applications, like residential, like commercial, even industrial.
It does so much damage, and it's usually a series of events. And just to kind of give an example, I've got an overheat situation, let's say a high return gas temperature. And maybe it runs the entire cycle, or maybe it kind of varies based on load. There's lots of scenarios that can happen out there, but eventually, maybe we start tripping off on motor protector at first. And somebody comes in there and, says, all right, and they move, or it's a discharge line temperature. So they move the discharge sensor 3 inches down the discharge line to minimize that 9 p.m. service call. I've heard guys talking about that, but you're compromising what goes on. But eventually that thing, we start to lose the viscosity of the oil. It's really all about the oil. So as you overheat the compressor, it's not just the windings in your motor, because remember the gas passes over them first in most applications, but what goes on with that oil? And if that oil starts to lose its viscosity, starts to cake and bake, used to be a terminology. I know you might have a picture of the one valve plate that you were showing me a little bit ago that you'll see it, and that oil just starts caking and baking on there, and then things don't work, and the reeds become brittle, or there's all sorts of things. So you bust a reed, just for example, or you come out and change a valve plate. You don't look into the compressor. You don't really look to see what else is going on, and all of a sudden you still have the same problem. And it's a unique, but like I say, there'll be a series of events, and we'll talk about that more too when we get into a few of the other ones. What causes the eventual failure? There's the root cause, I think was a term we used to use, and then there's a series of events that we can catch as a service technician, as a refrigeration mechanic. If we're familiar with things, we understand the equipment. Even sound sometimes. I grew up with the touchy-feely stuff sometimes to do that before you started putting gauges on, and vibration and sound and what it sound like when it starts up. That's not overheat. You learn to do that, and that's where you gain your experience at. Eventually trending valuable information like Trevor talked about earlier helps put the puzzle together.
Yeah, and exactly right. So you want to be aware of this stuff. What are some of the things that you see? So for sure, if you're running short on gas, what does that do to your superheat? Does that increase it or decrease it, right? So if you're short on gas, you're running high superheat back to that compressor. When you have high suction gas temperature, that means you're going to have higher discharge gas temperature. And so I was always taught it's 1-to-1 ratio. You increase that suction temperature by 1 degree, you're going to increase that discharge temperature 1 degree. So you need to be aware, and using your tools are so important. That's what it's all about, getting the tools out and taking tons and tons of measurements. That's one thing that I wish I did more of, taking more measurements. Like I did the basic ones that we'll talk about, but it would have been nice if I went in and did more along the lines, because after I was working at the manufacturer, when I seen them doing testing, they had thermocouples like every 8 inches. I'm not saying that you would do that in the field, but if you would have understand, okay, at the discharge line 6 inches from the compressor, and then at the inlet of the condenser, and then at the outlet of the condenser, doing these extra checks, it doesn't hurt. You'll learn so much more. And this is where I really seen it on CO2 systems, because they got temperature probes everywhere. And I can really, really understand what's going on with the system when I see all the temperatures and pressures all over the place. And just doing those temperature checks is going to make a huge difference. What else could cause overheating, Bob?
Well, a dirty condenser, I think, is probably one of the largest reasons. And that's a little more likely on that single compressor application,
Yeah.
to an extent. But remember, when you've got that larger condenser, there's a little room for there. But those guys take care of those condensers pretty good. But it's that single condenser that seems to really give a problem. And then when we start getting into high compression ratios, I think that's also something else that if we're trending in data and information, or we're able to do those calculations, and we know what it had been running at a given evaporator temperature, and we know outdoor ambient temperature varies depending on seasons and various things like that. But that high compression ratio would be one of the things that would really relate back to that. And just to relate back a little bit, when they do those testing in the labs and stuff, Trev, they put the compressor in the model shop. Those guys will tear it apart, and they'll put those sensors in, and they'll embed them into the valve plate, near the discharge valve, into the head. They'll even go down into not necessarily the inside of the cylinder, but into the crankcase. They can go in the motor compartment, and then they run those wires out to hook up their monitoring equipment. And they really can nail it down where the problems start and what happens with that. But look at that dirty condenser, look at your high compression ratio. Like we mentioned earlier, I think high return gas. What else might we add to that, Jeff?
Overcharged system, wrong refrigerant, or non-condensables. What happens when you have non-condensables in your system? What does it do to the pressures?
Well, you're displacing refrigerant first.
Yeah.
And it doesn't compress air or nitrogen. Those gases don't compress the way refrigerants do.
Yeah, so
they're
then
not a compressible material.
And I've seen this firsthand. I did it in the lab by not knowing there's nitrogen in the system. Was told that there was refrigerant in the system, CO2. Added a bunch more CO2, and all of a sudden I'm running super high compression ratio for that example. But there was other issues going on as well. Another thing, if you have variable speed drive on it, maybe, and you're slowing down and you're running real slow, and you get no mass flow coming back. We're talking about, you need that cool gas coming back. Metering device is another one. You might have the right amount of refrigerant, but if you got a plugged screen, what's that going to cause, right? Don't get in that gas.
It's restricting.
Cool. Yeah. So there's many, many different things. Could be a filter dryer. Could be a solenoid. There's lots of things that could cause overheat in your compressor. There's a few other ones that I never really thought about. Maybe your suction line. Think about where that's running. Is there insulation?
It's picking up extra heat, correct, Trev? Yep.
If it's running through a hot area and that insulation's bad, or there's none on it, or there's pieces cut, it'll pull that heat, suck that in, and bring it back. So you definitely have to be aware, and you got to look for this stuff. And sometimes it's not easy to find. You might be getting overheat, and you're like, how's the overheat happening? But you got to look, and it's usually in those easy places. Check the fans, condenser fans. Are they staging? Are they turning on? Is the right fan motor in there? RPM. So there's lots of different things. What else? So that's overheat. There's a few more things. Let's jump on to another one. What is another type of mechanical failure that you'd see it there?
Well, I would probably consider floodback maybe to be the next one that's a concern. And floodback isn't necessarily mean slugging in refrigerant cooled
That's
applications,
right.
but it does lead to what's called oil dilution. Slugging and floodback was kind of when I went to school and the apprentice program, they kind of laid that in that was going to be an immediate problem and immediate death. And that's not necessarily the case. Refrigerant has to pass over the motor first. And of course we want to cool the motor, obviously. It does get there, but if the refrigerant is in its saturated state and there's more and more of it, it drops down to where the oil's coming. Remember, the oil's coming back that suction line too. They mix together. It gets into from the motor compartment over to the crankcase compartment, and then it starts mixing with the oil. And at that point there, the pump is picking up. It has a pickup tube in the bottom of the sump, as we want to call that. And it picks that mixture of oil and refrigerant up. And the way we kind of always described it, it's pulled on up into the pump. The pump pushes it down to the first bearing in the crankshaft, and the heat from that bearing sometimes gets rid of that a little bit of liquid refrigerants in there. And now you don't have what I'm going to use the term, a full column of liquid pushing down through the journals, or excuse me, down through the crank and out the journals to lubricate the bearings. And so the farther you get away from the source, the pump and the first bearing, the farther you get away is where you end up with those issues that, we're not getting lubrication there. So now those bearings, they fail. And, one thing we always did in the teardowns, and I know and I know Trevor, you've done this too, is, pulling that oil pump off or that front cap or where it's at and shaking hands with the crankshaft. That's a very easy way to determine whether you've had a bearing failure in that back bearing. And remember, the main bearing is in the casting between the motor compartment and the crankcase compartment. And if that thing fails, that very tiny clearance you have between your rotor and your stator, and I know you've seen that and have maybe some pictures of where the stator drags on, or excuse me, the rotor drags onto the stator, and then eventually you get that electrical failure. The guy comes out and he gets the ohm meter out, he ohms that thing out, he's got grounded windings or open windings, maybe if it was a severe burn, and now he's thinking electrical again. And removing that oil pump is just an easy way to, without even tearing the compressor completely apart like we might in a complete teardown or in a lab situation or a teardown lab. But even in the field, you want to try to do that's an easy check that you can kind of see very quickly if you lost that back bearing. And that back bearing is holding up on that horizontal crankshaft. Now scrolls the other way around, but and the bearing is up in the top of the straddle bearing after there, and eventually it wears, and eventually the rotor drags too, or you get a flat spot kind of sometimes, so it goes back to that, and then when you energize the windings, magnetizes, the rotor doesn't turn, and then from there, then you go off on an overload, and you're out there again. We got an electrical problem, and once again, much easier to find in the semi-hermetic world than it is a scroll. But if you understand how it works and how it can play, and if you understand your system, then you can say, okay, we were having some issues with this before this happened, but that takes a little longer for that comparatively also to happen. But that series of events that lead up to the floodback, the metering device loses control. Just give an example. We dilute the oil. Back bearing starts to get sloppy, if you want to use that term. Eventually the rotor starts to drag. Then that electrical failure. So you've got this series of events that leads up to that. It's easy. And this is what makes the teardowns great when you go do those, is that they really get to put two and two together. And because we didn't necessarily think about that or understand that in some cases,
Yeah. And like you said about even in the field, like it's not difficult, especially on a semi-hermetic. You pump it down, you loosen the packing first, then you close the suction, you pump out all the refrigerant out of it, you close off loosen the packing on your discharge, you close your discharge, you electrically isolate it, and then you pull off the pump. You need a gasket though. Okay, you go get a gasket. You should have some of these gaskets in your truck if you're working on this stuff all the time, because it's all the same. I'm pretty sure it's pretty much all the same gasket for semi-hermetics. I'll have to double check that, but I'm pretty sure the gaskets are the same for all the pumps. Are the
you
same.
keep some in the machine room potentially too, that.
Yeah. And you don't have to drain any oil because your oil level shouldn't be over that. Your oil level should be below your pump. because that means you got too much oil in your compressor if it's above where your pump is coming off. So it's something that you can check, And I know some compressor manufacturers, I even seen an RSES video where they were actually measuring the play on the crankshaft to show that it's out, that the bearings wear, because you could shake it and there is some play sometimes up and down, but just a little bit. But I can't remember the exact number. And other manufacturers have that number because they can tell you, because you use feeler gauges and stuff, but they can tell you if there was wear on that. And easy for us is to shake up and down, back and forth play. There could be, but it's like you said, this is something very important. And some of the things that could cause, or you could see, this is an example right here. Like if you go to a site and you see a sight glass that looks like that, there's a good chance that you have floodback happening. A good chance. So what do? You get out your tools and you check. You make sure you verify that you're flooding back. Unless you put your gauges on, you don't 100% know. But when I see foaming like that, I think of floodback right away. And don't mix up, because I've heard this. It's liquid. It's liquid. You can't just say liquid. There's specific terms in our industry as technicians. It's liquid floodback, oil or liquid dilution, flooded starch. We're going to talk about all these other ones, but there's specific. If you just say liquid, oh, liquid broke that, because that's what I used to say. But there's specific terms to understand, and this goes for really all manufacturers. And you want to understand those terms, because when you're talking to someone, if you just told me, oh, liquid caused the failure, is liquid oil, liquid refrigerant, how? Well, you know what I mean? So this is something important that it took me a while to learn all these different mechanical failures. So take the time to learn the different ones. What are some of the things that could cause floodback? Let's talk about that.
Your metering device losing control.
There you go.
I think, or what we always just simply termed or tried to use the term was anytime the evaporator loses its load or control of the load, whether that be through a low load situation, somebody turning a thermostat or refrigerant controller down lower, the airflow across your evaporators. There's a nice, clear, clean air, not so clean example of a but very clear if you look at that from a service perspective. This thing hasn't been maintained in who knows how long, Trev. Anytime you lose that airflow, or it's just plug, that's just flat plugged right there. I'm not sure what they're doing or not doing in this store, that case, if we are talking about a supermarket here in this application. That's a big one. That honeycomb. Remember, a lot of times you're using that natural convection to move air around the evaporator, but the honeycomb becomes plugged and dirty, and it's just an airflow thing. But like I said, we generally termed it anytime it loses its load, or if you want to put it another way, the ability to absorb heat, because the evaporator's job is to absorb heat, and it's designed for a specific load and size. It should be able to properly absorb all the heat that it has going across it and change state of the refrigerant correctly to assure that only vapor is leaving the evaporator.
100%. Exactly. So anytime that refrigerant's not boiling off, you can run into that issue. Other things could be sizing of the valve, wrong TX valve. Like there's lots of different things that could cause it.
Wrong distributor.
Yeah, wrong
distributor pin in the TXV,
Yeah. And so there's lots of different things that could cause it. It's just you want to be aware of it. Adjustment. And there's so many. It could be fan blades. It could be the fans themselves. There could be lots of different things that could cause it. But these are the things that you need to investigate and take a look for, because this causes that mechanical damage on the compressor that leads to that electrical failure. Because this is it. I don't remember the percentage, but most of them compressors, 80% of them, you're going to go up and they're going to be electrical failures. But that electrical failure was caused by a mechanical issue. And this is something that you want to make sure that you know why that compressor failed, especially when you're getting into thousands of dollars of compressors. Because I've seen so many compressors replaced and there was nothing wrong with the compressor specifically, right? And it's important to take the time to find the root cause. And this is what customers are looking for. They're asking more. They're getting smarter. This is what your service manager or your foreman is looking for. What really caused the failure? And that's what we're looking for. That's what I'm looking for. What really caused that? So I know there's a lot of times where you don't have time to inspect it on site. You got to get that scroll in, for an example, and get it up and running. If you can't figure out what caused the failure, why that compressor wasn't running. You got to inspect it. You either got to send it back to the manufacturer or do it yourself. Because if you don't know why that failed, you don't know how long that next one's going to last. And that's the big thing. Because your time, your effort going there, pulling gas out, adding gas, all this stuff takes a long time. And our job is that you can't just do our job in you can't change the compressor in 5 minutes. It's just, you got to just drive and pick it up, the stuff. So it takes a while. So finding that root cause is so important.
Trev, one thing I was thinking about as you were talking there, also customer education, getting them to be aware of their equipment and what goes on. The one thing that we've heard many stories about doing the classes was the store personnel don't pay attention to the load lines. And especially when I've got that honeycomb application, and the guy, he's brought 4 boxes of bacon out or whatever it might end up being, and and he's filled it up to the load line. He's still got 1 box left. He just don't think he should run that back to the walk-in cooler again. So he fills it on up, and they just don't pay attention to that. And the customers opening and closing the doors doesn't help either in some cases. I mean, there's lots of stuff they do with that, and they design and plan for some of that. But there's just so many things that can lead to that. Get to know the personnel that are at your store or your carry out or whatever it is. Show them what a dirty condenser looks like, so that they can see that and say, oh, hey, and rather than them trying to clean it, they're calling you. They can do a little reach around, do some feeling on the air coming out of evaporators. They can maybe even potentially, if they don't want to encourage them to take panels off, but if the air's not flowing, that customer's aware that there's potentially a problem with maybe an evaporator fan or more, and the controllers too, that kind of tie everything together, do a pump down, whatever it would be. If they can just be aware of the controller, what goes on. And a lot of store managers are pretty good, and there's usually a site manager thing within the store manager's office that he can keep an eye on some stuff too. I think, especially in the supermarket world anyways. Customer education, getting them to be aware of how a problem can occur. It's their equipment, and they most of the time want to do so. They don't want to be paying to put compressors in most of the time either.
Yeah, it's building that relationship. When you
Yes.
build that relationship with that customer, I've been there. The customer's not very nice, and could be a different manager every day depending on the store. But most of the time, I'll tell you now that I've built a relationship with a store manager, with an owner, with someone who's taking care and the operations of there, that I build a relationship with. They trusted in the stuff I said because I cared. I wanted to fix the stuff, and I showed them. I took pictures and I bring them, and I did that. I showed them what's going on. Maybe their staff didn't really care, but they did. And when I went and I said, this is an issue, we got to look in it. We need to clean these cases. We need to clean this condenser. We need to change this, be proactive. They'll listen. But you got to build that relationship. And if somebody's different's going to that store all the time, it's harder to build that relationship unless you're going to that store all the time and it's your store. Because that's another thing. I've seen situations where there's a different guy there every second day. And then that's when they really get frustrated. They want someone there to fix the problem. There's another different problem that's different. But there's so many callbacks. And when it's your own store, you don't want any callbacks. And really nobody wants callbacks, right? And it's just caring about what you do, showing the customers what you did, being honest with them. Don't hide stuff. When you start to hide stuff, that's the issue right there. That's where the customers get upset. But yeah, so there's lots of different things for floodback. What's another one? So we talked about overheat. We talked about floodback. What's another mechanical issue?
About flooded starts.
Yeah.
That lead to slugging.
Yeah.
I think that can bring her down in some cases fairly quick, or cause some much quicker damage. Oh, there's a little damage to our Delta reed there, it looks like. This thing took what I call a liquid slug. And most of the time that is refrigerant, but we have seen some of these where all of them get busted, and it can be related back to what they call a hydraulic or an oil slug. That's a nice pick there, Trev. That's for sure. But yeah, slugging and flooded start and crankcase heaters, I think, are one of the things that are there. They have voltage to them, but undo the voltage, shut your power off to it and ohm that thing out and make sure it's still doing what it should do. Some of the smaller compressors, you can kind of feel if the crankcase heater is on. And some manufacturers will run the crankcase heater only when the compressor's off. and not necessarily when they're on. But if the system wasn't designed with a crankcase heater, the technician may in the field decide that, especially when he's changed a compressor like that. And, that's one of those extras when the OEM builds that, when the OEM orders the compressor. Sometimes they don't necessarily, you won't see that in the supermarket world per se, but in some applications, they'll leave that off thinking it's not a big deal. You're not running the air conditioning in colder ambient temperature. It happens. But anytime a liquid has a chance to build up into that crankcase of that compressor during the off cycle, and that's the key, it's off cycle, and then boom, and then all of a sudden the compressor's doing the Elvis shake, rattle, and roll. And if you're ever there, especially those larger semi-hermetic applications, whether they're Carlisle, Copeland, whichever it be, them puppies will move around like there's no tomorrow. And they eventually will slow down and get rid of that. And you pray that no immediate damage happen. But the more it does it, the more often, the more likely for that. I do know when they do the flood start test at Copeland, they'll start with a 25% overcharge. Just example on their test board. And then they'll start to see what the effects of that. And then they go to 50% overcharge. And they'll do 25 starts at that. And then they'll go to 100% overcharge. And they'll basically start it until it breaks. I mean, I've seen the guys do those. And, they're pretty durable machines. They'll take it for a bit. That Delta read you had there, that thing has went through so much engineering change over the years. It's quite a durable component for certain. And look at the cast iron scrolls. That's the fixed scroll there. And literally what we call clear the deck. I've literally seen the compressors, especially turning at 30, 34, 50 RPM, try to compress the pieces that break off. And as it moves it toward the center. But that one, I guess when he took the fixed scroll out of that, or the orbiting scroll, all the pieces just fell out. But boy, that really cleared the deck. And don't think scrolls can't take flooded starts, or don't think they're immune. Yeah. They do have that tolerance that the scrolls move over, and that sideways movement, that allows for a little more tolerance to the whole thing. But over and over, there's your pieces down there. I see maybe another application, but see, I'm not seeing any signs of overheat. But you see all those little circular things up through there. We've had quite a bit of dilution there, and then there's been some wear where the tips run onto the flanks and the tips touch each other between the fixed and the orbiting scroll. You shouldn't see those sort of wear patterns whatsoever. Not seeing any overheat at all in that thing there.
Yeah. And so this is important, what you need to look for, right? You need to look for this in semi-hermetics. You got to pull the compressor apart to find it. And no different in scrolls to figure it out, to figure the failure, because that compressor could have had an electrical failure. Could have been still running, maybe. You don't know. What'll happen is that if you're having these flooded starts, liquid migration going back, all of a sudden there's a massive explosion washing all that oil away and potentially metal on metal. And like Bob said, you have those scroll galling, that causes efficiency losses. So anytime you have a flooded starts and you get those grooves in there, there's gas bypassing each one of those flanks. And so now you're losing an efficiency. The compressor's still running, but it's not as efficient as it was. And you really want to take the time to figure out what causes the migration to cause that slug, or that flooded start that leads to the slug, and that slug leads to the electrical failure. So there is this process that you need to look into and figure that out, the root cause of it. These are the things that you want to look for, right? Flooded starts are something that, once again, on scrolls, you don't see it look inside those compressors. It's easier to find in those semi-hermetics because you pull it off. And once again, you can't just say, oh, it was liquid, because not necessarily it was liquid refrigerant. It could be oil that caused the slug.
Especially in the scroll.
Yeah, definitely could be liquid, because you have that massive explosion. You got liquid refrigerant underneath the oil, and that oil flies up in there and does the damage. So these are some of the things that you want to look for.
Was anybody dealt with a system that had a solenoid valve for pump down prior to shut off, where your low pressure switch controlled your compressor contactor rather than a thermostat using that? What happens if that solenoid valve is bleeding through during the off cycle? And that's something you're not going to see. Typically, you're not there to watch compressors that aren't running, but there's lots of things that can lead up to that, that you can plan to minimize that migration due to off cycle. But, if the solenoid valve bleeds through, or, there's just too much going on, the evaporator's flooded more than it should be. potentially it can also come back if you didn't get that all boiled off. And then the off cycle, especially if the evaporator was higher than the compressor. Now you should have trapping and you're supposed to do all those things when you pipe the system up. I have seen issues with that. Make sure that cylinder valve really works and low pressure switch shuts off at the right point. And remember, scrolls aren't meant to be pumped down all the way. So you don't necessarily set those low pressure switches as low as you would with the old reciprocating applications. Understand your system and what's supposed to minimize that, and the better off you'll all be too.
Yeah, 100%. So we talked about overheating so far. We got into floodback, talked about flood starts. What else is there? What else is out? So we talked about those three. There's still more.
Well, we always listed from Copeland's perspective, especially in the mineral oil days. And I kind of, since I kind of started that's where we were at when I got in the trade. And there's other things that we did or didn't do right back in them days. But loss of oil was always considered to be an issue. I think what's taken that over, and I don't want to skip over loss of oil, but contamination is becoming greater and greater as we've moved to more HFC refrigerants, POE oil. Those things have been a problem for certain too. But when you lose all the oil, there's not much going to happen in this. There's going to be no lubrication in this thing. This thing's going to seize up, break those parts like that. We called that ABU back in the day, Trav. You might have heard.
Yeah.
Wow, that's a pretty neat picture there. Where did you get that one at?
Well, it's out of a biscuit compressor, but it's the same thing. Like, you need to look inside the compressor. Is it loss of oil or is it slugging that caused it? What happens to those rods? It's on journals, it's on a crankshaft, and if you got no oil, what happens to it? Seizes up to it. And then when that time it goes to start, you can snap the rods. Or it could be that flooded start that caused a slug to damage it. So you need to investigate. So is there oil in there? Is there not? Is there overheating? Is there not? This is why inspection is so important. Even on scroll compressors. Or hermetic. Same thing with a hermetic. If you have 2 or 3 compressors fail, you need to check it, because what's going to happen in the next one and what causes it. And like we talked about oil issues, like one of the main things is you run into piping design issues. Do you have the proper traps? Do you have separators? Do you need separator? Do you got super long runs, 300 or 400 foot runs? Do you need to add a separator to that to keep the oil at the system? Also, low temp application. What happens to the oil? Gets super cold, right? It gets very viscous, it gets thick, doesn't move as well. So all these different things that you need to look at. Oil is another one that is hard, because if you don't have a sight glass, even if you do have sight glass, oil is hard even on a supermarket system when you don't really understand the full dynamics of it. Like the viscosity is so important. That's something you need to start learning more about, understanding oil. A lot of people don't understand. I didn't understand it while I was in the field as good as I should have. It takes a long time to understand, where's that oil at. If the oil's too hot, it's not good. If the oil's too cold, it's not good. So there's a fine balance when you're doing loss of oil issues. That's for sure.
Happy medium. One thing, Kevin, I was thinking also too, and looking at this, you were talking about how to distinctly tell the difference between a loss of oil and a slug sometimes, and it can be a little difficult. But if you can get that crankshaft out all the way and inspect all those bearings and journals, generally with a loss of oil, you'll have a very even wear pattern. And the front bearing, the journals, the back bearing, everything is going to have a pretty even wear pattern in a loss of oil situation. With slugging, the refrigerant may pop up by just one journal and one cylinder, and you're good in the front, you're good in the back, but it's that center journal on where the rod hits onto the crank. It shows just the wear, but the same wear pattern, the same eventual result is the ABU we see here. But look for that. Just one thing, that if you get into a complete teardown, look for a very even wear pattern with true loss of oil.
Yeah, and you're talking about contamination, like when you take a look at scrolls, hermetics, even semi-hermetics, and you see what you see here, right? This is caused from contamination, right? Moisture in your system causing breakdown of that oil. Mineral oil, they used to see it when you had a lot of overheating. You'd get some of this looking like this, but POE oil is moisture. A lot of moisture and some heat, and it goes to all the hottest parts. You start seeing this stuff, you got to be thinking, what did I do on my install? Or who did the install? Because this is stuff that comes up years down the road. And for me, I call this contamination in a system too. Even though there's some manufacturers that say, okay, well, we can use dyes in it. For me, it's contamination. You should have refrigerant and oil in your system. That's what, unless it's an oilless system.
You
But
know,
for this here, if you see
that's
this stuff, you need to understand what caused that, and because you could have an electrical failure, and if you didn't open up that compressor and you didn't see this, well, what's the issue?
one of the things we always had to distinguish too was the difference between overheat and contamination. If you can wipe it clean with your finger or a rag easily, it's probably not overheat. So
Yeah.
that's one thing to kind of think about too. If it comes off easily, it's the oil's being contaminated and it's causing some problems. And you can see on those discharge pucks there, that's some yucky looking stuff on those things right there. And if it's got the yucky looking stuff there, is it seating and sealing correctly?
Yeah.
Potentially not, right? Same with your reed valve too, which is not shown in there. It's missing in the picture, but are they sealing correctly? You know, you need a thin film of oil there to help seat that every time it opens and closes, and you don't get the blow by. You know, blow by is another thing we didn't really talk a lot about, but you get that wearing in the cylinder wall or on the in the rings, and then when you go to compress, the refrigerant, it pushes not just out the discharge valve, but blows back into the crankcase. Now that pressurizes your crankcase, and now that can create some issues too. Well, there's a good overheat there. It looks like, or is that contamination? Looks like you could wipe that clean, don't it? Yeah.
It's just to take the time to look, and you're not, to be honest, it's going to take a lot of inspections. It's not just you look at one and all of a sudden you're going to always figure it out, because there's lots. I've inspected hundreds and hundreds of compressors, and there's some that I just didn't know. So what you do, you take pictures, as many pictures as you can, the tops, the bottoms, the fronts, the backs, everything, and you send it to the manufacturer. And so hopefully you can get someone that can take a look at it and give you some advice on it, because that's what I did on many occasions, and it just took time and time again just to learn. Well, this one here, what would this cause?
Hang on just one second. One thing to add to that. Consider most of your wholesalers will have a refrigeration specialist too.
Hopefully.
So develop a good relationship with that wholesaler. We don't always think of that unless you really already have that good relationship with that wholesaler. But whether it's Bitzer, Copeland, Carlisle, whatever it be, there's a specialist that has went to many trainings with them, if not all of them. Generally, they're not going to concentrate on just one. There should be a technical specialist that's within the group of your wholesaler that can really help you out with a lot of stuff too. And they can help you with that compressor that's out of warranty that's failed to get it back for that inspection. Because you can do that. Even if it's out of warranty, it'll cost you a couple bucks, and really more than a couple dollars. But but it's really, for what it costs, the valuable information you get, and saving the next compressor is important.
Yeah.
But yeah, develop a good relationship with your wholesaler, because they have the folks there that are very astute in things. So yeah, just want to kind of add that in there, Chuck.
Yeah, for sure. And then and if that wholesaler that you're working with now is not really helping you as much, there's a lot of them out there. There's more wholesalers than you even know. There's for Copeland, there's 500 or 600 in the U.S. and there's hundreds in Canada. That's a lot. And then Bitzer has tons. Dorin is coming into the market, so they're going to have a lot more. And then you got LG, you got Tecumseh, you got Daikin, you got Trane. Like there's a list of a lot of different people that can assist. So if you're say you're working with someone that's not really working for you, find somebody else to work with. Right? That's what it is, building those relationships. Here's a condenser plugged up. What's that lead to? Air,
High
no
head
airflow.
pressure.
Yeah, high head pressure, high compression ratio. Or you pull
That's
it
a
apart.
pretty dirty one there too. That it should never get to that point if the customer is having you come out and do those planned maintenance things.
Yeah, it depends on where you're at too, though. There's some places that it could be every month that it get plugged up, so that's something to think about. But this is something you talk about with your customer and try to get done. Like we didn't
In
really.
the city of Dayton, Trevor, years ago, there used to be a lot of manufacturing, and of course, they weren't as strict on emissions and things like that in the day. It was just amazing. Sometimes these condensers on some of this rooftop equipment didn't look dirty, but when you started putting your cleaners on them, the black stuff would just roll out.
Yeah.
Because there was a very thin film of this stuff that was in the air, and especially when you were near any of these large GM plants like we had, or the manufacturing plants for brakes and all that stuff, and a lot of machine shop. You never thought about that kind of stuff. But the condenser would look fairly clean. But boy, when you started cleaning it, you noticed the difference, and you could watch that head pressure drop. You noticed the better improved flow. It was really kind of amazing.
Yeah. Like this one's another one from a Slug. You got a blown head gasket. Can you replace this stuff? Sure. If you got no damaged stuff inside that compressor, there's things that you can replace. But you got to do a bunch of different tests. You can't just go and, okay, it's a head gasket, I'm going to put a head gasket. Well, does the compressor have a bad wrist pin? Does it have bad bearing? All these different things you want to check. If it's a semi-hermetic, if it's a hermetic, then and it's not running, you can't get it started. And you make sure that there's no special device inside that hermetic compressor that's keeping it off, because I've seen this time and time again. It could be the internal protector off. It could be sensors in the windings that's keeping it off. It could be ASTP. There's lots of different things that could be keeping it off. It could be a drive that's keeping it off. It's on a variable speed application, and you think the compressor has the issue. You really want to just make sure and verify, because I've changed compressors before that weren't failed because I made mistakes and I didn't take enough information or didn't give it enough time. And I'm just trying to give you some advice to take that little extra time. You got that time, especially on bigger applications that help the customers. Sometimes they're not going to be pleased. Either way, you're not going to always make them happy, but you want to make sure you do the best job you can.
Well, with that gasket you're showing there, that's blown. And if they've determined that the compressor doesn't have enough damage to replace, they have to put a new gasket in place. We would always recommend no kind of gasket sealers or any of that kind of stuff, just a very thin film of oil. And usually it wouldn't be the POE oil. That's not going to be good on your skin and that's, but just a very thin film of mineral oil on each side of that gasket. And then the proper torque specs in the proper cross pattern is also very, very important. That calibrated forearm, as we would jokingly say, is not enough to truly do a proper torque on those. And the manufacturer is very particular about that. And that's one of the things when they tear a compressor apart, they'll check to see especially if they can tell the gasket's been changed, and they usually can. But just very thin film of oil on that, clean before you put it on, put everything together, and then the proper torques with the proper cross pattern.
And it's important to get into the different guides for the manufacturers, right? So here's the Bitzer one. So for an example, it's training.bitzerpv.com/literature. Just go to Google and write it. And there's lots of different things. But if you get into service guides right here, just like the application engineering bulletins for Copeland, this is the service guide. And then right here, Ecoline service guides or recip service guides. If you're working on these compressors, this is gold.
Trevor, I don't know if you guys will be able to see this or not, but this is a Carlisle service guide, very thin book that I found. I wanted to get. This is what we grew up on. I bet you've never seen one of these, Trev. Copeland Electrical Handbook.
Not that one, but I've definitely.
I know you've seen them. But yeah, these are old timey stuff, and these are the things that I kind of grew up with. And today, to take advantage of this stuff, the way we can find that information online, like Trevor's showing here, is just huge. We didn't have that. We didn't have that smartphone. It was what you learned and what you did wrong, and then finally figured out what was right in some cases.
Exactly.
But it's great to have information. I think that's what the ultimate goal is.
And this is an example. This does not take long. If you're resourceful, you don't need to know all the facts because you can find them. That's the big thing. You can find the facts, so you can put other knowledge in your brain. You need to think on your feet. That's the big thing. That's what a lot of contractors are looking for, people that can think and troubleshoot, because you can go find this information. So right here, like 250 max discharge temperature they're looking for. Oil temp, they're giving a good example. Superheat, minimum, normal. Oil pressure differential. This is just examples that easily took just a couple of minutes to find. You could just go on Google and find this stuff. It's important to do this. Tecumseh has this stuff. LG, you name it, Carlisle, it doesn't matter. You want to spend the time. Danfoss has really good information. I may not have mentioned that before, but their manuals are hands down some of the best. But all these big manufacturers, you can get in and look at it and find this information. It's so important.
Trev, I think one of the questions was what's the name of the app for Bitzer?
So that one is the B-Spot app. I think it is B-Spot app.
Okay.
Yeah, and then if you go onto their website, they have a software called the Bitzer software where you can find it for each specific one. And then it's no different. Like if you go to Bach, you can find them on Bach. Or if you go to Copeland, it's OPI, and go into AE Bolton. So all these different places. It might take some time to do this research, but this is so important to do this stuff. Take the time after hours to find this stuff. I remember when I was younger, I needed to get paid for everything. That's something that held me back for many, many years. So I didn't know different because people told me you don't do anything in refrigeration unless you get paid. The dumbest thing I've ever listened to. And I just didn't know different. I was young and foolish. You got to take some time, invest in yourself. It pays off. It definitely pays off.
Sure, that's why I got an education. I wanted to share some of the experiences that I had. And starting off at the tech school and working my way through the union halls and working with the national groups like NATE and AHRI now, and education became a passion. And I did have a lot of help with the gal from ARI back in the day, Leslie Sandler, who was their director of education. And she really convinced me that this is a great thing to do and that we need this. And this is why, and then when nowadays there's so much access to these like Zoom meetings, Trevor does, and every time you turn around, there's a new pathway for information, and you need to take advantage of that as much as you can. But guys, share the information you've gained and learned with the younger fellow on the job too. I think that's important.
Yeah, so important. I got a question here. If you have to make gasket, the thickness is critical if you work in remote location. So one of the big things there, those manufacturers give you the thickness. Like you can go into I know in the application engineering bulletin, 4 and 6D compressors, you find the right one. It'll tell you the different thicknesses of the compressor.
I think there's like 4 different thicknesses on that 6D, depending on temperature application or something like that. If I remember, that's going way back to be thinking about. But yeah, there was a choice. You got to make sure you get the right one. That's a great question.
Awesome. Anything else, Bob? How can we leave this? Because this is
it's just a matter of this is the thinking man's trade. The more you know, like we've already said 4 or 5 times, the better off you are. But learn the processes of troubleshooting, learn the process of identification, become familiar with the equipment, and trend your information and your data, and it will serve you much better, I should say.
Yeah, for sure. Take the time, figure that stuff out, because it is important to do that. And when you start learning, taking the time to find that stuff, it's just gonna find the root cause of an issue it's gonna just benefit you that much more. And I really want you guys to do good out there, get better, grow, share this knowledge. What me and Bob talked about over the last 3 sessions, share the knowledge with other people, because this is how we're going to get the industry better. We want to grow it together. We want to make sure that our industry strives. And it's why we strive is from people just like you coming to these events, hanging out, learning a little bit, and sharing this knowledge. We want you to share this stuff. Bob, how can people get a hold of you and where you're going to be to really help others out?
I have a training and consulting company. A lot of the training here in South Florida is meant to be in person, but I do some consulting. I can help with industry certification. I'd love to help any company that's interested in gaining more knowledge, knowing where to get knowledge. You can reach me at Bob, HVAC, the number 1, at me.com. And awesome. Just remind me where I met you. It would be, if you want to email, you could ask me a question about anything too. I know Trevor is always available too, but I try to stay active, and I'm still involved in a lot of national industry stuff. I'll probably be up at ASHRAE for sure. I may be at the symposium. We'll see how that works here in Florida. But anyways, I like trying to get around, and maybe at the instructor workshop, maybe you've seen me there before if you've been out to that, but done lots of things. I did sheet metal, introducing sheet metal to your HVAC last year. So that's I got a pretty broad knowledge, and I love to share it.
Yes, awesome, Bob. Thank you so much for doing this. And for anybody else, I have a bunch of training programs coming up. I got a compressor masterclass, and I got them running a couple times a year. Supermarket program coming up. I think they're almost all full. CO2 program, it's full, so I got to set another date in the spring. But if you guys are interested, head to refrigerationmentor.com and click on some of the courses. Check them out. We're here to help. We want you guys to get better. We want you to grow. I want you to learn this stuff. I want you to think on your feet, get better, and show up all the other people at your company, because you are the one investing in yourself. You are the one that's spending the time to do this, and it's only going to pay off in the end. I really appreciate all of you coming to hang out. And if you guys have any questions, reach out. Shoot us a message, reach out to me on social media, and really want to help grow you guys.
Excellent.
Have a great one, everyone.
Thank you, everyone. It's been great. Thank you, Trev.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.